This scenario might look familiar to you because we had almost this identical graph. We had that almost identical equation when we first started learning about quadratics applied to real scenarios. But there's one subtle difference now in this example. We're still following an object that travels through the air and it achieves a maximum height of 49 feet. It starts out at a height of 24 feet. I'm noticing all this because these are the y values and the y-axis is height. But in our previous example, the x-axis represented a distance. So in our previous example, after traveling forward 5 feet, it had achieved a height of 49 feet. When it eventually got to 12 feet, it had a height of 0. But in the example we're working on here, the x-axis is going to represent time instead of distance. So in other words, now after 5 seconds, we're at a height of 49 feet. After 12 seconds, we're at a height of 0 feet. So just like we did in the previous example, you could figure out the height at any time along the way. Now we're used to using x and y in a t-chart, but really we're now thinking about the x value as a time value, and the y value is really a height value. So if I plugged in a 2 into my h of t equation, you can see all the math right there, I would eventually get out a 40, which means 2 seconds into the flight, this object that was thrown is at a height of 40 feet. I could do that with a 9 as well, and I did that down here. It's at 33 feet. So the only difference in this scenario versus the previous scenario is the x-axis is representing time. It's not representing a distance. So just like before, we can review all parts of the anatomy. For example, here's my vertex. And since the x-axis represents time, that 5 represents 5 seconds, that 49 represents 49 feet. So I can say my vertex represents the maximum height of 49 feet after 5 seconds of travel. So I can now interpret the y-intercept and the x-intercept. This, as you know, is the launching point of the object. So we can say after 0 seconds, or initially, the object is 24 feet in the air because we're launching it from on top of a roof. That was the original scenario. And then eventually it hits the ground. There's 12, 0. That's an x-intercept. And basically we're saying after 12 seconds of travel, the object hits the ground because it has a height of 0. The domain and range of this scenario, you can get them from looking at the graph. The domain, which represents the x values, never gets smaller than 0, never gets bigger than 12. So it goes from 0 to 12. But that also makes sense because you can't really go into the negative time range. And any time after 12 seconds doesn't seem to matter because after 12 seconds, that object is just sitting there on the ground like a sleeping cat. The range goes from 0 to 49. 0 is the lowest y value we have, and it's the lowest height we have because this object isn't going to go negative height. It never gets higher than 49 feet. That's the vertex, which is the maximum height. So there's our range. And the axis of symmetry is the line that would divide this graph right down the middle so that the right side is a mirror image of the left side, and that is the line x equals 5. And I know it's the line x equals 5 because it's the vertical line that hits the x-axis at 5. The only real difference in this scenario that we've just gone over compared to what you have learned previously is this axis is representing time and not distance.